Okay, guys, if you think back to Tuesday, what you had to do was write proofs, just like we're going to be doing today. But if you think back on it or look at the worksheet, you'll see that all of them were 3 lines long. And there were a couple that I had you skip that get a little longer. We're going to do those today. But all of those proofs were just 3 lines long. It's pretty straightforward. It's about as simple as a proof can get. It gave you 2 congruent elements of the triangle. You had to find the third, and then you're done. So honestly, we didn't get great practice with the highlighters because we just highlighted everything. Today it's a little bit different because if you look just here at this first one, where it says our givens, angle B is congruent to angle E, and then DC bisects EB, segment EB. So we're going to have to do a little bit more work with these, and I'm going to introduce this idea of how to handle something when it says like DC bisects EB, or something is a midpoint, or something is perpendicular. So you always kind of handle these in a similar way, not the same way, but in a similar way. All right, so let's go ahead and get started with this one. And to start it off, we started off the same way. It's just writing down the givens. I'm not going to tell you how many lines are in this proof yet, but I'll start doing that later. So angle B is congruent to angle E, and DC bisects EB. And those are given. So you've got 3 different colors, just like we did last time. You'll use your pink, yellow, and blue. It doesn't matter which color goes to which. But I'm going to use different colors up here. And just understand, we're just color coding so that we can keep track of our progress. And keep track of the diagram, how it's all evolving. One thing on this that I did a little differently is that I took out the triangle congruent statement, the second half of it. So maybe that's the first thing that we can do. Remember that you have to write triangle congruent statements specific ways. So if you look at your proof statement real quick, it says that triangle EAD is congruent to triangle blank. Now, if it's EAD to begin with, what does the other one have to be? BAC. Okay. And if you're not sure, just remember, imagine you could actually transform those triangles and get one to land on top of the other. Which point is going to land on top of which point? So you can see E and B will land on top of each other. D and C will. A will land on top of itself. Okay. So we're going to work with that proof statement, and that'll be the last thing that we do. We know we're done whenever we've got 3 congruent elements. We only have 1 right now. Angle B is congruent to angle E. I'm going to underline that one. You can highlight it. And I'm going to mark in the same color up here. Just so I've got 1 congruent element, 1/3 of the way there. Still need to get 2 more. I think before I want to worry about that bisect statement, let's go to the diagram, see if we can find anything. You guys notice anything in the diagram? We got those vertical angles. So I'm going to go ahead and mark the vertical angles in kind of this bluish color. And I'll write my next line. So I'm using vertical angles now. And what is my statement going to be? Angle BAC equals or is congruent to angle EAD. Okay, this looks similar to the proof statement, but keep in mind, for the proof statement, we're trying to prove the 2 triangles are congruent. We've just shown here that the 2 angles that we wrote down are congruent to each other. So I'll pick a different color. This is saying something is actually congruent. I marked it in blue up in the diagram. I'm going to underline that in blue right here. Of course, with highlighters, just highlight the whole statement. Whatever helps you. So now 2/3 of the way there. And now we get to this last little bit. They never give us givens that aren't going to be useful and necessary. So if they told us something that wasn't necessary, then it wouldn't need to be there, and they wouldn't have even put it in the first place. So it's going to be necessary to know that DC bisects EB. So let's think about what the definition of bisect is for a second. What is the definition of bisect? To split in two. To split in two randomly, or to split in two how? Evenly. To split directly in half. Exactly in half. So, if DC bisects EB, which segment was cut? Yeah, we have to do a little bit of English here when we're doing these proofs. You have to think which one's being cut, which one's doing the cutting. What matters to us is which one was cut. And EB was the one that was cut because it was bisected. And like you said, according to the definition of bisect, that means that this was cut exactly in half. So what does that tell us about the two halves? Yeah, EA and BA are equal to each other, because they were cut directly in half. All right, stop doing that. So I've got my kind of purple color. Hopefully you can see it clear enough from there. But I went ahead and marked that those two segments are congruent. In fact, I'm going to go ahead and write that in my proof. So segment EA is congruent to segment BA. So now we get to the last little bit of this that's a little bit tricky, the reason. But once you see this a couple times, then it'll hopefully make sense for you. So to determine that EA and BA were congruent, we thought about the very definition of bisect. So we said, according to the definition of what bisect means, these two have to be congruent. You guys with me? So here's our reason. We just write down the definition of bisect. And I always abbreviate definition as DEF of bisect. So this is the key thing, and I want you guys to remember this. Anytime there is a phrase in your givens, and look at all these proofs, all of them have phrases like T is the midpoint of blah, blah, blah. Or in this case, DC bisects EB. The first one is not a phrase, it's a mathematical statement, a congruent statement between two angles. But this is just a phrase, DC bisects EB. Anytime you have a phrase, you will have to use a definition of whatever the word is. So when we get down to midpoint, there's going to be definition of midpoint. To the one next to this is we've got perpendicular, so it's going to be definition of perpendicular. So anytime there's a phrase, be prepared to use a definition of whatever term is used. Okay, is this making sense so far? Okay, I hope this is easy. It's adding one extra wrinkle to what a proof looks like. And now we've got, how many congruent elements have we found now? 3. What can we do next? There you go. We can write our proof statement, the triangle congruent statement. So we already figured out what that's supposed to be. It's supposed to be triangle EAD is congruent to triangle BAC and the key thing with this, and I tried to emphasize this on Tuesday, but really want to re-emphasize it today and continuing forward. If you have a triangle congruent statement, you have to pair that with a triangle congruence theorem. So we can't put anything here except one of the 4. Side, 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 angle, side, angle, 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 side. Okay, there you go. This one is angle, side, angle. All right, and yeah, you can narrow this down by realizing that we have 2 angles and a side. So what that means, it's either going to be angle, side, angle, or angle, angle, side. It's definitely not side, 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 or side, angle, side. Okay, so yeah, you realize that the congruent side is between our two angles, which tells us ASA, and there you go. QED. We are done. So that doesn't add too much difficulty to your proof. I know it's kind of a new thing. We haven't talked about it yet using definitions, but it's not too bad. And now you kind of know the trick. If there's a word there, a phrase, then you need to use a definition of that phrase. I'm going to skip B, and we're going to come back to that one because that's going to be our longest proof. And that one gets slightly more complicated. But we can jump down to C, and this is actually problem K from the handout I gave you guys on Tuesday. I told you to skip it, but now we're going to do it. All right. And this one maybe looks a little bit more challenging because it doesn't give us any given. Or sorry, it gives us givens, but it doesn't give us any congruence yet. It tells us a couple of things are bisected, but that's about it. So let's go ahead and write this down. BD bisects ADC. And on the next line, I'll write the other one. BD bisects ABC. So I'll show you later on one of these when the givens, when there's a lot of givens and you don't want to write everything down, you can just kind of circle it and draw an arrow. And I'll show you that, but this isn't too much. We can write a couple of phrases down. All right. So let's think about our next step. We know we're going to have at least 3 more lines before we can do a triangle congruence proof, or the triangle congruence statement. We need to prove 3 congruent elements. So we're going to have 3 lines to show congruent elements. All right. So you can kind of think through it logically that way. And are there any congruent elements you guys can tell me right now? Say that again. You're saying those 2 segments, A, B, and C, B? Oh, ADB? I'm sorry, I just can't hear you, sorry.
I said A and B and C and D.
Okay, well, we don't know that those are congruent. We do have something right in the middle that we know is congruent. What do you got?
A and C.
A and C? Well, again, we don't have anything telling us those are congruent. They might appear to be, but there's no angle relationship between them. It's not like they're vertical angles or anything like that. That's okay. Are you saying angles B and D or segment BD? Segment BD. All right. So segment BD, what property are we using here? The reflexive property right here tells me that, and that is a shared element, that side. So I can say that BD is congruent to BD. Again, if you put BD and DB, it doesn't matter. So these 2 are congruent because of, like you said, the reflexive property. And we've got 1/3 of the way there. The next 2 shouldn't be too difficult. I mean, at first it might be, but once you see one of them, the other one will fall into place. We've got our givens here. BD, segment, and I'll spell it out. Segment BD bisects angle ADC. So let's kind of look at the diagram and figure out what that's telling us. That's saying that this segment right here in the middle, BD, is cutting angle ADC in half. We already talked about bisect. So if we're cutting angle ADC down at the bottom of our diagram in half, what do we know about this angle on the left? Okay, the angle on the left and the angle on the right have to be congruent because this was cut in half. Okay, so I'm going to start with the reason, actually. So what do you think our reason is going to be? We're about to show that those two angles are congruent. We're going to write that down. But the reason for it is definition of bisect. All right, we're basing this on that given that they gave us. And so we had to use the definition of bisect. Definition of bisect kind of acts like a translator. It turns it from just a phrase into a mathematical statement, a congruent statement. So I can say two angles are congruent. What are the names of my two angles? There you go. AD. Well, AD what? B. So ADB is going to be congruent to angle CDB. All right, 2/3 of the way there. Not too bad. You guys following along with it? Okay, so one other given statement. So, I mean, you don't have to actually show this, but I kind of just used my first given. I'm putting a check mark beside it. If you want to, for your own benefit, kind of keep track, okay, I already used that given to help me find something congruent. I have another given that I haven't even really looked at yet. That one says that BD bisects ABC. So what can we say about those angles at the top? These angles at the top also have to be congruent, so I'll show these right here. Same reasoning, but we have angle ABC, and we need to be able to identify this. This is why knowing how to name angles is so important. But ABC is the bigger angle up at the top, and that segment running right down the middle is bisecting it. So that's how we end up with this. We've got that two angles are congruent because of, what's our reason on this one? Same as before, definition of bisect. All right, so name those two angles up at the top. ABD and CBD. So I'm going to stop right here because this, we need to make sure this is really clear. What's potentially not clear on this is that lines 3 and 4 look very similar. All right? So you can imagine, maybe for yourself or maybe for other students here, how it can be very tempting to just, or it's very easy to see them as saying exactly the same thing. But these two lines are telling us very different things. And it connects back to the diagram. The very first one is ADB, CDB. Those two angles are congruent, which are these two angles down at the bottom of the diagram, marked in blue. The next one is saying ABD and CBD are congruent, which are the two angles at the top of the diagram, marked in purple. So we have to have both of those statements, and both of them are equally important, even if they look almost exactly the same. Okay? So, are there any questions on what we've done up to this point? Okay, and just to reemphasize the point made before, we used bisect right here in the phrase, or it was given to us. So we need to use the definition of that word in order to come up with our congruence statement. All right, so I've now used the other given. There's no more information to find. I've got 3 congruent elements. So I'd say we're ready to finish this off. What do you guys think?
Yes.
Okay, so let's write this now. Triangle DAB is congruent to triangle what?
DCB.
All right, DCB. And in this case, the reasoning is angle side angle. Any questions on why it's angle side angle? Okay. Just to reemphasize, look at what you're given, look at the diagram, look at the proof itself, what you've written down, and you can narrow it down to, in some cases, narrow it down to 1, some cases narrow it down to 2, and then pick from there, looking at the diagram closer. So anyways, it's always going to be very obvious what the answer is if you look close. All right, I am going to jump down to F. And I'll go ahead and tell you how many lines are in this proof. This one's going to have 5 lines. So we're going to pretend like this is a test. I give you that much. And you guys have to write this proof. Of course, I'm not making you do it on your own. We're going to do this together. All right, but it's good to know going in how many lines are in the proof. We can go ahead and fill in part of this. So what can we fill in right now without even having to use any? All right. So we can do T is the, I didn't give myself a lot of room to write, but that's okay. Midpoint of ME, and then T is the midpoint of GJ. That's given. Neither one of those is a congruent statement of any kind. So I'll just leave it like that. What's that? There you go. So yeah, we can start with the midpoint because Logan just pointed out what midpoint, how we can use that. All right. So go ahead and say that again.
If it's the midpoint, then that would get split in half.
Yeah, this is kind of the same as bisect, just phrased differently. But yeah, and so Logan had it right. So if T is right in the middle, then we're splitting it in half. All right, so let's just start with the first one. T is the midpoint of ME. ME is that longer segment going from the bottom left to the top right. What can we say about the two sides of it? MT and ET. Yeah, those two are congruent. So MT is congruent to ET. And what do you think our reason is going to be? Is a definition of midpoint here, but you're right, it's the definition. So this is what I'm saying. Just look at what term is used. In the first two examples, it was bisect. Here, it's midpoint. And I'll go ahead and show that's one of our unknowns. So we can use the same logic for the next one. What do you think the next line is going to say? Segment GT is congruent to segment JT. And I'll show that on the diagram real quick. I'm going to mark that in blue. And I'll underline this one in blue. And you guys pick some color. And the reason for this one is definition of midpoint. Okay. So, and if we're kind of keeping track of the givens, we already used the first given. When we said T is the midpoint of ME, we used that to get two congruent elements. Then T is the midpoint of GJ. We just used that one too. So we've gotten all the information we can out of the givens. Now we need to look at the diagram, find one more congruent element. What is that going to be? All right. Great job. Vertical angles right here. I'll go ahead and write down the reason, vertical angles. And so if they are vertical angles, well, they are vertical angles. So what is the actual statement going to be? Okay, there it is. Angle GTM is congruent to angle JTE. The important thing is that T is in the middle as your vertex. If you switch it around, ETJ, MTG, that doesn't matter. But T has to be in the middle, and the two endpoints have to be there. So I marked that in purple. I'll underline it. There you go. 3 congruent elements. So sure, this complicates our proof a little bit, but is it that bad? No. Okay. If you are struggling with this in any way, you can get help and we can go through some more practice. But hopefully going through these examples today is making it pretty clear. The last thing to write now is... Someone go ahead and tell me my last statement. Well, it starts off MGT is going to be congruent to EJT. There it is. This is one some students struggle with in first hour. It's a little bit difficult, but just remember, like I already said, just imagine that you could rotate the triangles so they sit on top of each other. G is going to sit on top of the J, M is going to sit on top of the E, and T sits on top of itself. And the congruence theorem for this one is going to be side, angle, side. Remember, if you're given two sides are congruent, and right now you can see in line 2 and 3, we've got sides are congruent. Line 4, we've got angles are congruent. So it has to be side, angle, side. If it's ever two sides and an angle, you don't even have to put more thought into it. Just, okay, it's a side, angle, side, QED. All right, I want to do one more as a class. We're going to go back to B because I told you it's the longest one on the page. But I guess before we do that, is everyone good? Any questions on this so far? Okay, let's go back to B. And this is going to have 6 lines to it. So let's go ahead and write that out. 1, 2, 3, 4, 5, 6. All right, so this is an example of a proof where there are a lot of givens, and I don't necessarily want to go and copy all those down again. So I don't mind for a problem like this if you just circle the whole thing right here and just draw an arrow to say, hey, these are my givens, and they go on line 1. You still need to write down that they're given on the right side. So this one's a little bit strange in that it's our longest proof, and yet they already give us something that's congruent. All right, so I'm going to go ahead and show that. VCB and DBC, those angles are congruent. So VCB and DBC are congruent. Not only that, but we can get another congruent element in the next line. What is that? The reflexive property there in the middle. So I've got that this line is going to be used by both triangles. So in this case, what is it? BC. BC is congruent to itself because of the reflexive property, and it is shared by both triangles, so that's why I am writing that down. Honestly, we could use the reflexive property for everything in this triangle, but we only use it when it helps us prove triangle congruence. Okay. So now, let's look at what happens next. Okay, let's think about the definition of perpendicular. What does perpendicular mean? It's not that. They intersect how? At a 90-degree angle. At a right angle, 90 degrees. So we're going to focus on that 90 degrees. And let's go ahead and write that. So we've got VB. The segment on the left is perpendicular to VC, the one on the top. So if those two are perpendicular, that means that it's a 90-degree angle right there. So I'm just going to say this. I mean, I should write technically the measure of angle, but we're doing it this way to make our lives a little easier. So angle BVC is equal to 90 degrees. And the reason for that is there it is. So remember, if you have a phrase, you will use the definition of whatever keyword in that phrase is at some point. Okay, I bet you guys can tell me the next thing to do. C. All right. There might be some struggle naming it, but what is it? Okay, we can call it BDC or CDB. It doesn't matter to me. So BDC, D is the vertex here. We're talking about CD, that segment on the right is perpendicular to DB, the one at the bottom. So that means that the angle formed between it, which is angle BDC, is 90 degrees. For the same reason, I'm going to do a shorthand. So if you want to do definition of perp for perpendicular, or I'm going to do definition of perpendicular and write the notation. I'm fine with an abbreviation or substituting it with a notation. Okay, I've got that one angle is 90 degrees, another angle is 90 degrees. What can we say? Not, well, yes, we can do that actually, but for our purposes, they are congruent. These two angles that are 90 degrees are congruent to each other. So angle BVC is congruent to angle BDC. And I'm going to go ahead and mark those on the diagram. So there's my right angle there. Here's my right angle right here. Those two are congruent because of, now this is where it gets trickier. What do you guys think we're using? Not that. No. I'll go ahead and write it down. Yeah, we're substituting. All right, but let me tell you what you guys can do for this if this ends up being kind of tricky for you. So anyways, angle BDC is 90 degrees, so I'm just taking that and I'm going to substitute it in for this 90 right here. And that gives me that those two are congruent to each other. Does that make sense?
Yep.
Okay, now here's the thing. Suppose this proof was on the test, and you got down to this point, you had this written, and you couldn't figure out, you forgot it was substitution. You could write out a phrase, all right? In fact, you could do this for any line that you want, any justification. But if you forget what to call something, but you can justify it with kind of writing out your logic, that's fine. So in first hour, some people were telling me how they came up with it, but they couldn't remember substitution. They said something like, well, if they're both equal to 90, then that means they're equal to each other. So if you wrote that out, if they're both equal to 90, then they're equal to each other, that works for me as your justification. That's kind of a rephrasing of the substitution property. Okay? So anyways, so I'm giving you that as an option. So if you ever get stuck on a test and you're like, I know the reason, but I cannot think of the what to call it, well, then don't worry about what to call it. Just write out your reasoning. All right? So we're good with that. We've got our 3 congruent elements. Let me underline this one in purple. Now we can do our triangle congruent statement. So BBC is going to be congruent to what triangle? Okay, make sure you guys are seeing this. BVC, if you rotated that triangle around, it would land. B would land on C, B would land on D, C would land on B. Yeah, it has to be CDB. And make sure you put the triangle symbol. Okay, and the justification for this is angle, angle, side. We've got 2 angles that we found to be congruent. We've got one side that's congruent, and the side is not between the two. So QED, we are done. All right, this is one of the more complicated proofs. So if you understood this, I would say it really doesn't get more complicated than this. We're going to introduce one other thing tomorrow, but I would say this is probably the most complicated you'll see. So how do you feel about this one? Do you guys feel like you were able to follow the logic of it?
Yes.
Except the substitution? Okay. Yeah, and that's probably the single trickiest part of this entire thing. But what you can do, like I said, and I just want to reiterate, if you forget what to call your justification, just write out a phrase that explains your logic. And if you do that in a way that makes sense to me, I'll give you the credit. Yeah?
How do you know if it's side angle, angle, or angle, angle, side?
You can write, actually, side angle, angle works. We just always call it angle, angle, side. But if you wrote side angle, angle, you'd get credit. Yeah. Okay, so you guys still have about 8 minutes. What I want you to do is pick one of the other proofs that we didn't do. Both of them are 4 lines long. So if I just come over to D, yeah, I can spot you this. And it doesn't matter which one you do. They're both 4 lines. See if you can figure out how to do those proofs.